Excellent. Where do we put him? So big. Thank you. Nice to be here. I'm Chet Haas from the Android Developer Relations team.
And I'm Romain Guy from the Android Toolkit team.
And today we wanted to talk about modern Android development, which internally and externally, I guess we abbreviate as MAD because that's what we do.
What's that? You first found the acronym and then you figured out what it means, right?
It's all about the wordplay, absolutely. So this is the name of a talk that we've actually given several times before. In fact, 2.5 years ago, we gave it in Paris at Android Makers. And then a week later, we gave it at Devoxx France. And then later that year, we gave it at Google I/O. And then in Android Developer Summit a year later, we also gave modern Android development. And then sometime, I think in Greece and maybe 1 or 2 other places, we kept giving this talk called modern Android development. But this talk is different. That was really more about comparing what people used to do to what developers now do and some of the recommendations that we have. It was a bit more historical, giving the context of the things that we do as modern Android developers. But now we mean specific things when we use that phrase. And that is what we're here to talk about today. So why don't we start out by talking about classic Android developments. And my co-speaker disappeared right at the point where I thought he was going to talk about this.
I'm back. 1 second.
Oh, dramatic pause. All right.
Dramatic pause. Right. So Android, the first public SDK was released at the end of 2008. It was named M3 for Milestone 3. And a lot of the things that you're used to seeing in Android today, like all the fundamentals were already there. So we are using the Java programming language. We had some of the basic foundations in our platform APIs, things like intents and activity, the view system, APKs for distribution. We're going to talk about that in a little bit. The main difference was that we're using a completely different IDE. We're using Eclipse, the Android Development Tools, ADT, which was a plugin for Eclipse. About a year, that was the end of 2007. A year later, at the end of 2008, we released Android 1.0. And then after that, for many, many years, not very much happened in terms of, actually a lot happened, but nothing particularly interesting in terms of changing the programming model or the way you develop Android applications. Until 2013, where we completely changed our development toolkit. So we switched from from Eclipse to Android Studio. Again, we'll talk about that. Then we spent a few years working on that new platform. And finally, when we are done with all that, we started listening even more to application developers, what they wanted, and how they wanted to build applications, what kind of language they wanted to use. So that's when we added support for the Kotlin programming language, officially supported as of 2017. We introduced a new series of libraries, the architecture components. And on the Play Store side, we've also tried to make it easier to bundle large applications with multiple features with app bundles.
So when we talk about history, we can talk about different elements of this. In general, modern Android development, we sort of have these 4 pillars or areas that we're going to go into. And one of those is language. So in the classic Android programming model, we, of course, introduced Java programming language as the programming model for most Android applications. There were many reasons for this, many really good reasons. One was there were a lot of developers that actually knew it. So we were coming out with a new platform, and it's kind of nice to not have to change everything in order to program for this new platform. So the ability for people to actually use a language and syntax that they were used to and programming model they were used to was really good. There were free tools out there, such as Eclipse, so that we could write our plugin for it, and we didn't have to expect that developers would have to buy expensive development tools to actually develop their applications for the new platform. There were a lot of existing libraries and middleware that people could just use out of the box or at least learn from. There were patterns and best practices about how they wrote their code using the Java programming language, although, frankly, some of those needed to change because of the performance constraints that we had in mobile, which were a bit different than programming to desktop and servers at the time. And obviously the memory management, we take this for granted right now, but Java programming language is one of the first languages with built-in runtime, so you didn't need to think about allocating memory and then freeing it very manually. Instead, it sort of happened automatically for you, which again simplified the programming model and made it easier for people to come on board.
So we already mentioned Eclipse a couple of times, and ADT, our plugin for Eclipse. There were many reasons why we went with Eclipse. So first of all, it was a very popular IDE back then. It is a very powerful IDE with tons of features. It was one of the first IDEs for the Java programming language, introducing the concept of refactorings, for instance, which was very, very useful. So a lot of developers not only knew Java, but they knew Java through Eclipse. So it was very easy to onboard people if we provided, a similar developer experience. We already mentioned a couple of times that Eclipse was free, which of course was meant for us to lower the bar again, more for developers to get started in the mobile world. And Eclipse is more than an IDE. It's actually, there's the RCP underneath, so it's a full platform. It's meant to build not only plugins for the IDE itself, but you can build entirely new applications. And I'm sure you may have used some of those applications yourselves. So for us, the team was pretty small back then. We only had a couple of people working on tools, and being able to reuse all that existing platform and all the existing capabilities was extremely important for us to be able to quickly deliver high quality tools.
And it was free. All right, on the API side, on the libraries, basically we had the platform. We had all the APIs that we shipped with the platform really, really frequently. We'll see a timeline soon, and you get a better sense for exactly what was going on at the time. There were often, actually always, 2 releases in development at the same time, but sometimes even more than that. The team was running very fast to ship all these things out because they were really playing catch up in terms of the features and functionality that a mobile platform needed at that time. There was new sort of amazing new stuff in every single release, and there were fixes for all the bugs, all the time. And so you really needed to sort of be up to date with those releases to get all of the functionality and the performance and the fixes that you really needed for robust applications at that time. So here's the timeline. You can get a sense for how fast the team was running. 1.0 came out at the end of 2008, and then at the end of 2009, dot release. Was that the Petit 4? I believe.
It was Petit 4.
And then 1.5, the first dessert named release, the cupcake, and then 1.6. You can see these are just like months apart here. And 1.6 was like 1 month away from 2.0. What was it? You were saying 2.0 was actually done before 1.6 shipped?
Yeah, we finished 2.0 before 1.6 shipped. Which
so
makes
run. Yes. Shipping, continually, and then sort of a little bit more time in there, but still sort of 6-month cadence here until we come out with Gingerbread. And then there's the Honeycomb release, and then things start to spread out after that. And then in recent years, we've really developed into an annual cadence, which is good from a couple of standpoints. One is it's certainly easier for the team to not have to be working quite so much on quite so many releases all in parallel, but also developers find it a little bit easier to consume new content and new features with a more measured pace, and also partners and manufacturers. Like it's difficult for them to consume all these and then qualify, and then once they've finally qualified a release for their devices, to then have to qualify the next release if it just came out. So annual releases are really a better cadence in general for everybody concerned. So that's where we're at now.
All right, and the way you were distributing your apps at first was through APKs. So APKs stands for Android package. It's just a zip file with a slightly different name and some conventions about what you find inside, right? So there's classes.dex, there's the resources that have been precompiled, but there's nothing really that magical about APKs. So zipped, to be able to deliver apps at a smaller size. But the problems started to emerge as Android was growing, right? As we started shipping on more devices, especially once we reached things like TVs and tablets and so on. All those configurations would find their way into the same APK. So you had the choice between making a bigger APK with a lot of data that most of your users would never need, so that was completely useless, in terms of downloads and storage, or you need to split manually your application in multiple APKs, which was a lot of work and could be very inconvenient. And again, it started like not as an issue because in the early days of Android, not just Android, right? Like the state of the world of mobile development back then, apps were a lot simpler. Like the apps were not made of multiple millions lines of code. So this is a problem that only started appearing over time.
So if we look at those four areas again, we can see some of the problems. We've referred to some of the problems as we went, but let's take a look. So on the language side, you've got the Java programming language, great for some of the reasons that I mentioned. It's still a good answer, but it is verbose in terms of modern languages that many developers have become familiar with. Need to write a lot of code, a lot of boilerplate code to get stuff done, and there are maybe simpler ways to go.
So for tools, again, we mentioned that we're using the ADT plugin on top of Eclipse. And there were some challenges with that as well. So first of all, it was difficult to customize. We were just writing a plugin. We did not have any control over the platform. And Eclipse is used by so many companies and so many groups out there. It was very difficult to try to influence some of the changes we wanted to have. And for instance, at least a long time ago, progress in some areas like support for the Java language was going slower than we wanted, but it was difficult for us to do something about it. Also, because of the nature of this plugin-based architecture, it was great because you could have multiple subtools and you could integrate like a bunch of different plugins from different sources, but that led to like somewhat inconsistent UIs. There were also some benefits. It was very easy to turn some of those tools into standalone tools. So for instance, our tracer, our profiler called TraceView was both a standalone tool, but also available as part of the Eclipse experience inside the IDE. And yeah, last bullet I already mentioned, we did not have control over the future of Eclipse, which was a bit of an issue for us.
I remember often going to talk to the SDK team and asking them if we couldn't make this thing a little bit different or better. And the answer was often, we do not have control over that part of the system, so we just kind of have to work around that constraint. It's very dissatisfying. All right, and then on the API side, as I said, we released all these APIs, all the functionality in the platform, which is great. Everybody gets the same thing all the time, and it's all built into the devices, so you just use the code that's there on the devices. But developers were limited by what their user base had. So the more releases we came out with, the less developers could depend on a single experience or even a single set of functionality that users actually had on the devices that were running those developers' apps. So this became a disincentive for developers to actually adopt the newer technologies that we were coming out with every release, because they would look at us and say, well, that looks like a really interesting feature, and I'll talk to you in a couple of years as soon as my users actually have access to that feature on the phones that they're buying. And that was true for fixes as well as the features, and then they'd have to have workarounds in their code just in case users were on older versions and they hadn't been upgraded yet. Also, some of those early APIs were complicated, and there were good reasons for that. One is that, frankly, mobile development is complicated. It includes everything in the world, right? You may be talking to backend stuff. You may be dealing with local storage. You certainly have to deal with performance constraints, battery constraints, display issues, different kinds of displays, different formats, localization, like every programming problem in the world thrown into this one little tiny package with energy and power constraints. And so it was somewhat complicated just because of the nature of what it was, but it was also complicated because the team ran really fast and created APIs, sometimes built around these early performance constraints that were maybe hard for developers to ingest and then live with forever, because that's the way that platform APIs work, because they need to be backward compatible forever. So some of the areas that certainly kept coming up were lifecycle in Android is difficult to deal with. Storage is hard, whether it's app storage or shared storage or web storage, back on the server side or whatever. Navigation through apps and the app versus back, the up versus back button, how do you make these experiences consistent?
And then for APKs,
yeah, go ahead.
Yeah, go ahead. Yeah, for APKs, I already discussed what the problems were, right? Like either you had multiple APKs, which was difficult to handle and distribute, or you just had one very large APK, which was bad for your users, especially a few years ago when storage was much more limited or data plans were much more limited.
And so the answer that we have come to, not immediately, but I would say we're combining many of the things that we've done on the Android team in the last few years, is what we are now calling modern Android development, which I wrote a sentence around, so I'll just go ahead and read it to make it a little bit clearer. Modern Android development is development tools, APIs, language, and distribution, which are those 4 categories that we already talked about. Technologies recommended by the Android team, I guess that's us plus a lot more people, to help developers be productive and create better apps that run across billions of devices. So if we look at those 4 categories, we have languages, tools, APIs, and distribution, all sort of sitting on top of, I drew this figure. I went way out of my way to draw this amazing pillared structure because I think very literally we think of the pillars of modern Android. So there are the pillars, and they're all sitting on the foundation of the platform, as well as the Play Store technologies. And we just take that for granted. So that's not what we're talking about with modern Android. Instead, we're talking about these categories or these pillars that sit on top of it that are the more optional technologies that we really recommend that people pick up because it will make it easier to create better applications. So this talk is going to go a bit more in depth into each of these categories and tell you more about what we mean and examples of that, starting with
the programming language, Kotlin. So based on our own statistics, 70% of you listening to this talk are already using Kotlin. So we'll proceed based on that assumption. So a bit of history for Kotlin, the timeline. So Kotlin is a project that started several years ago. It's a programming language created by JetBrains. JetBrains is the company behind IDEs like IntelliJ IDE for Java programming language, but they do other IDEs like CLion for C++. They do PHP Storm, Python IDs, and a lot of other things. So in 2016, Kotlin reached maturity. It reached 1.0. And we had already heard of Kotlin, because we're interested, but because folks in the community were also looking at it. But when it hit 1.0, we saw a rise in interest amongst our professional developers mostly. So we decided to take a closer look at it, which is why in 2017 at Google I/O, we announced that Kotlin would be officially supported on Android. So what this means for us is that we would guarantee that new versions of our toolchains, of Android Studio, of the Android SDK, would not break Kotlin developers. Before that, you could definitely use Kotlin for development on Android. Actually, you can use any programming language that compiles to the Java bytecode or directly to the text bytecode. So you can use Scala if you want or whatever else. But sometimes, changes we would make would break those workflows. So we committed to supporting Kotlin in particular, because there were many things that we liked about Kotlin that we'll talk about in a second. And we went a step further last year where we announced that we're going Kotlin first. So we saw great adoption. If we look at the top 1,000 apps that are in the Play Store, we see that over 50%, now it's closer to 70%, I think, of pro Android developers use Kotlin. It's one of the fastest growing languages in our industry. And we saw that developers who use it are definitely happy with their choice. So that's when we decided to pull more weight behind Kotlin. So for instance, we started building libraries that are written entirely in Kotlin. Again, we'll get back to that. And finally, earlier this year, so during the Android 11 beta launch that replaced Google I/O this year, as far as Android is concerned, we mentioned that coroutines are our recommended way to do async programming. Did we mention that at Android Developer Summit? I don't remember. Anyway, we said that if you use Kotlin specifically, you should use coroutines for async programming. And that's where we are right now. So why Kotlin? There are 4 main reasons. First, the expressiveness, then the safety of the language, the interop, and structure concurrency. The best way to look at this is just to look at some examples. Structured concurrency is all about coroutines. I'm not going to go into the details of coroutine because this is a vast domain and you probably know more than I do about this particular topic. But if you have never used coroutines, I strongly recommend you take a look. And obviously, interoperability with the Java programming language was a plus for us because that means you can move to Kotlin without having to rewrite your entire application. You can just adopt at your own pace, which is huge. Again, applications today on mobile are big. They contain a lot of code, and it doesn't make any sense to rewrite, to start from scratch. So with Kotlin, you don't have to. So here's a small example written by Chet. So if you want to criticize the code, please direct all the questions towards him. So first, Kotlin has the concept of nullability in the type system. And it's interesting, I think recently Florina from DevRel published an article on Medium mentioning that we saw more bugs being caught by that than we thought it would. So it's very interesting, like the ability to add a type system, make the difference between something that can be null and something that cannot be null, has been helping applications crash less and developers like make fewer mistakes. Then we have first-class support for lambdas. Lambdas are language construct that's available in many languages. One of the things that Kotlin does really well is this trailing lambda syntax. So when the lambda is the last parameter of a function call, you don't have to pass the lambda within the parentheses of the function call. Instead, you can just open the curly braces and put the code of your lambda. It makes for very clean code. It almost feels like you're adding new features to the language. And this is, for instance, a cornerstone of what we do for Jetpack Compose. This is what makes Jetpack Compose possible. Extension functions are a great way to structure your code and to expand on existing APIs. So here we're calling the capitalize method on a string, but the string does not have a capitalized method. So this was added as an extension function. Other languages have done that before, but this is great to have it as part of Kotlin. We rely on that a lot as part of our Kotlin extensions, the KTX libraries as part of Jetpack. And we use those to take existing APIs, for instance, the platform APIs, and make them more Kotlin friendly. And we'll see a better example in a little bit. You also have template expressions, so you can put Kotlin directly into your strings. You don't have to do a lot of like string concatenation by hand. Support for property access. So when you have a getter and a setter at the bytecode level, you can just use this property syntax, which makes code easier and cleaner to read. So another reason why we picked Kotlin was speed. So here we're not talking about speed of the runtime. We're talking about speed of the velocity of development, right? It's all those language features make the code easier to write, also easier to read and easier to maintain. And the language itself like evolves at a really fast pace. A great example is coroutines. JetBrains has been iterating a lot on coroutines, but as soon as they released them, they kept innovating. And for instance, they added flow support right after they ship coroutines. So we know that the language is evolving at really fast and maybe sometimes a little too quickly. It's hard to keep up with all the new versions, but this is a good thing because it delivers a lot of value over time really quickly. We mentioned, a lot of you are already using Kotlin. Kotlin, you can already see that between the screenshot of the slide where it's at 50%, now it's at 60%. Those numbers keep going up, and that was already from May 2020, so about almost 6 months ago. So clearly the interrupt story is working. A lot of you have been adopting Kotlin and are reaping the benefits. We mentioned that we're Kotlin first, so that means that our teams are doing a lot of work to better support the Kotlin workflow and development. So as part of our tooling, we've been adding lint checks. So we're helping you like make sure that you write idiomatic Kotlin or Kotlin code that's friendly for the compiler or the runtime. We have a dedicated compiler team at Google. So we have people who work directly on the Kotlin compiler in collaboration with JetBrains. It's also the team that works on R8, the DEX optimizer and shrinker. So we've been adding a lot of Kotlin-specific optimization to R8. So when the Kotlin compiler generates code that's not optimal for Android, we use R8 to correct what the Kotlin compiler has been doing. And also, obviously, we work with JetBrains to make sure the compiler generates better code in the first place. We've also introduced recently a new project called the KSP, the Kotlin Symbol Processor. This is a replacement for KAPT, the Kotlin annotation processor. So this is a way to process annotations, to do annotation processing faster. And I'm sure you all want your build times to be smaller, and this is a way to get there. We're also working on the platform APIs themselves. So the platform is still written using the Java programming language, and the APIs are written in Java. But we can do two things. A, we can augment our APIs with several annotations. So for instance, nullable and non-null, which help the Kotlin compiler understand the type system a little better. We also have recently nullable and recently non-null. So this is a way for us to basically do nullable and non-null as a warning instead of as an error. And after release, we switch the recently annotations to the real ones, and then you start getting errors. We have an API console internally where we look at all the new APIs and we try to make sure that the APIs feel like they were created by the same team and that they're as good as they can be. And we do take into account the specificities of Kotlin to make sure that that we don't repeat mistakes that we've made in the past. Like, we don't have setters that take multiple arguments because this goes against the property syntax of Kotlin. I already mentioned the Kotlin extension libraries. So those are a series of small libraries that take advantage of Kotlin-specific features to augment existing platform APIs. Those live outside of the platform, so we can release them as often as we want. And the best way to show you the benefit of those KTX libraries is to show you an example. So on the bitmap class, we have this function called create bitmap. It takes a width and a height and a configuration for the bitmap. And then let's say that you have a drawable and you want to draw that drawable inside the bitmap. So the drawable has a draw method that takes a canvas. And to draw the drawable into the bitmap, you have to write all that code. You have to extract all the bounds. You have to change the bounds of the drawable. You have to resize the drawable to be the size of the bitmap. Then you create your bitmap. You create a canvas for that bitmap. You draw the drawable, and then you restore the old bounds. So it's not hard, but it's a lot of cumbersome code, and there's no value in that code that you're writing, right? Like everybody is going to write the same code over and over again, and you probably wrote that code a bunch of times. So instead, in our KTX libraries, you have this toBitmap extension function on drawable, and it uses default values, so you don't have to specify a width and a height. We can use the ones from the drawable directly. And the way you use it is you just call drawable.toBitmap and optionally with the width and height, and that's all. So again, no magic here, right? We just wrote the same code that you saw on the previous slide, but it takes advantage of all those features of Kotlin. And we have like dozens and dozens of those small APIs that just make your life a little easier. By being Kotlin first, that also means that we want to create Kotlin-specific APIs. So for instance, for Room and Work Manager, we've been adding support for coroutines. So if you use Java, you still have access to the existing APIs. But if you use Kotlin, you can take advantage of all the benefits of coroutines. Paging 3 is a complete rewrite of the paging library. It's been rewritten in Kotlin from the ground up. And obviously, one of our biggest projects to date, Jetpack Compose, it's a brand new UI toolkit. And that one is written not only exclusively in Kotlin, but it also works because we wrote a Kotlin compiler plugin. So we extend the Kotlin compiler itself. So we could not write Jetpack Compose using the Java programming language.
I want to jump in here on the paging 3 when we just posted a podcast like last week with the paging engineering team, and they explained a lot of the decisions behind that rewrite. And it was really mostly about internal implementation and making things more robust internally, as opposed to now they get to expose suspend function API, coroutine APIs to the callers. So if you're thinking about coroutines in Kotlin for your own code, it's sort of an interesting investigation into why that was advantageous, especially for the asynchronous programming model that they needed for paging.
Yes, and of course, we're doing more than just API and tooling. So our DevRel team and our tech writing team has been really busy with extra documentation, samples, code labs, courses. We have tons of articles and videos. And that are being released weekly to really help not only newcomers, but also seasoned developers figure out the best practices on how to use Kotlin with our APIs.
And now let's talk about tools. That would be you again.
Me again. All right, so tools. Like I said earlier, in 2013, we announced Android Studio, so our new IDE based on IntelliJ, the IDE from JetBrains. And the tools team has been able to move very quickly since we moved to IntelliJ. So we do not control IntelliJ itself, but we work very closely with JetBrains. And as you can see, we work more and more closely with them with our relationship around Kotlin. And after doing the initial transition to IntelliJ, we've been able to start innovating quite a bit. So in 2016, after when we introduced constraint layout, we also introduced a new UI editor, so the new constraint layout editor. That's also when we deprecated officially our support for Eclipse. Then we followed up with Android Studio 3.0. So we had the full Kotlin support again, meaning that we would not break Kotlin at all. We introduced a series of new profilers to replace the old ones that we wrote originally for Eclipse. In 3.1, we added support for D8, which is a better way to compile your application directly to text code. It's faster. In 3.2, we added more profilers. So now you have energy profiling. You also have systrace, which you used to have to invoke from the command line. Now you can do it from the IDE, and you have a cool new UI to see the results. And in following the model of constraint layout, where we develop the library and the tool at the same time, for navigation, we'd say it would be great to have a visual tool to help you visualize your navigation graph in your application. So that's something we released in Studio 3.3. 3.6, we added support for view binding. Same thing, the support in the IDE was written almost at the same time as the library itself. And 4.0, recently, earlier this year, we released the motion editor. So that's based on the constraint layout, the motion layout. And it's a new way to not only design, but also preview your animations directly in the tool. So you don't have to run the app over and over again. And you can do really complex animations. All those releases paint a picture where you can see there's a tight integration between the libraries that we build and the IDE itself. Of course, the IDE, we picked IntelliJ because it is a very powerful IDE. It has really good refactoring. It has support for plugins, so we can extend it easily, just like we used to do for ADT. We do collaborate with JetBrains on the core. Obviously, there was already tight integration with Kotlin, with Gradle. We had support for quick fixes and min checks, so we've been able to add a lot of our own quick fixes that help you figure out better ways of writing your code. And again, we're trying to follow that model of building libraries and the tools at the same time whenever possible. So this is why we have the database inspector, the layout inspector, navigation graph, and stuff like that.
All right, so much for language and tools. Let's talk about APIs. And when we talk about the APIs for modern Android development, we're pretty much talking about Android Jetpack, but not all of it, because Android Jetpack is huge. It's really a subset of Android Jetpack. Jetpack is over 80 libraries or something massive, including app compat and stuff. But you can think of the modern APIs that we're referring to here as sort of the architecture components plus, the things that are sort of their goal in life is to simplify Android development, look at the pain points, and create solutions that make it a lot easier to deal with these complicated problems. So if we look at the modern APIs that we're talking about, I sort of think of it as starting out with constraint layout, which Lama already mentioned, developed in conjunction with the tool inside of Android Studio, of course. And then architecture components 1.0 came out with life cycles and view model and room in late 2017. And then we came out with paging and navigation and work manager supports later in 2018, and then material design components. So material really started out as a design spec, and then we built Lollipop around that spec, and we told developers, this is a design language that you should use to build better looking applications. But a lot of it was left up to as an exercise to the developer, and material design components encoded a lot of those design ideas into these components that you could directly use, so that you sort of get that design language for free in the applications that you develop. And then Jetpack Compose was announced and started developing in the open as of I/O last year. And we also announced Camera X, which is currently in beta. And I'll talk about that a little bit later. And then finally, Motion Layouts came out along with Motion Editor in its stable release just a couple of months ago. So now you have a way to not only build UIs that have this really rich animation built into them, but also design and edit those things within a visual tool, which is certainly a lot easier if you're dealing with complicated animations. So if we walk through some of this functionality, we take a look at constraint layout. I think of this as being relative layout plus, which is it's the ability to position and associate views in the hierarchy relative to each other, but with a lot more capabilities built in, partly because there's a design tool, but also just underlying capabilities in the API. The ability to, say, draw key lines or guides in the screen and then align to those. So not just the other views on the screen, but really align very richly to the design system, the design grid that you have in the application. And then underneath constraint layout, we have this motion layout subclass of it, which allows you to basically design a UI around the concept of transitions, where you have a constraint layout start position and you have a constraint layout end position, and motion layout will either automatically run an animation between the two of them, or allow you to design a very custom animation with a lot of tools built into both the API as well as the design tool itself. And one of the complicated areas, as I mentioned before, of Android overall is this idea of life cycles. And you basically needed to study this diagram and understand it very deeply, and then implement all the concepts in your code. And inevitably, developers would have a hard time getting all the details right, which would result in things like leaking activities and therefore running out of memory, or potentially crashing the application, referring to something in the wrong part of its life cycle after it was already dead. And then we had these APIs. The way you would typically do this, or a lot of developers did, is they'd have this activity subclass, and then they'd put all these methods in there, because really this was the only way that you could track the state of the life cycle of your application, is to override these methods that were going to get called when the state changed. And in the new world of modern Android development, this is no longer a necessity. You should still have a basic understanding of what it is to be paused and resumed and started and stopped. So you sort of need to understand what the life cycles are, but there's a much easier way to plug into the system. So instead, both activity as well as fragment classes that you subclass are now lifecycle owners, which means that you can observe on these. You listen for changes in state outside of the activity code. So you no longer have to take all of your application code and shove it inside the activity, which is absolutely the wrong way to go. But maybe seemed obvious to go that way just because of the way that we had designed these life cycles. So now instead you can observe on changes, and then you can find out later in your observer, you will get a call saying, hey, this application is in the start state, resume state, pause state, or whatever. You can also, and I think this is the stunning part, actually query the state. And you could never strangely do this before. You couldn't actually ask the activity or the fragment what state it was in. We knew internally, we just didn't give you an API for doing that. But now you can. So at any particular time, if you want to make a decision about doing something, you can find out whether that is consistent with the current life cycle of the application. So all of these changes make it easier to move to a more ideal model, where we separate the notions of what is going on in the UI from what is going on in the data, or the model of the application, because now we have this loose coupling between them, and you could observe for changes. So when the data changes, you will find out about it, and then you're going to get a callback, and then you can do something about it in the UI, and you no longer have to put all of that code and logic together into this very tightly coupled model that tends to get pretty ugly pretty quickly. In a typical model, your data is going to be sitting on top of some sort of database. Here, we suggest you use Roam for local persistence, and that's sitting on top of a SQLite database. And then you're going to do the same observation and callback mechanism as before. Also, Room uses coroutine to implement these suspend functions. So now, like, it was always the requirement, if you're going to talk to your database, you really need to not do that on the UI thread. Well, how do you do that? Well, it's tricky, right? So you set up this complicated callback mechanism, and you have these really complicated code paths that maybe weren't obvious to either create or to read and maintain in the future. But now, using coroutines and the magic of suspend functions, it's much easier to actually be on the thread you want to be on, but make a call into a suspend function that is going to do the right thing somewhere else. It makes your code much more readable while still adhering to the constraints of that asynchronous programming model that you need when dealing with databases from UI elements. So now we have something like this, where paging can then expose lifecycle information in a different way, and you can observe on this paged list. So you can observe in a similar way, and then you find out changes to the entire list at that time. And then we also made a big effort through all the architecture components to make them work together. So we're not, separate engineers coming out with separate libraries and APIs. Instead, most of these people are on the same team, or they at least collaborate very closely together to make sure that these things work together. So view model live data, they're all lifecycle aware. So that you've got these sort of similar mental models that carry forth throughout all of these things. Room, you access that through these view model objects. Again, sort of consistency all across there. Room uses coroutines and flow. And that helps keep all of those really expensive or potentially expensive accesses off the UI thread as they should be. I should point out, though, that although we are offering all of this to simplify developers' lives, we understand that a lot of developers are already using RxJava. You may love it. It may be throughout your code. It's hard to change now, and maybe there are great reasons for you to be using RxJava, and that is totally fine. You do not need to convert to this new stuff, but the APIs that we have in the architecture components are RxJava friendly. For example, we asked about that in the podcast on paging. We're asking about that because obviously they expose great Kotlin API using coroutines for paging 3, but they also have 2 other APIs depending on your programming model, one of them being very RxJava friendly. So if you're in the Java programming language world and you're using RxJava, that will work just fine. So navigation component was another one of those architecture component things to come out, and another great example of working well with a visual tool. Not only that, but now in the later releases of Android Studio, starting with 3.6, when you create a new application, a lot of the templates that we use for those actually come with navigation built in. So if you create a basic activity, it will actually give you destinations for navigating automatically. And then you can go into the visual editor and see those destinations, change the information, add destinations, add properties, all of that stuff. Now, if you're looking at a visual tool, you should probably automatically think, oh, well, what does the XML look like? Because certainly in the current world, until we get to the interesting Jetpack Compose world, the visual representation that you see on screen is closely linked to an XML model underneath. And that's certainly true for navigation. So the code for those destinations that we saw in a visual way on the previous slide is represented by these. You have these 2 fragments, and then you have the actions that define the navigation between those fragments. And then in your code, you would then call navigate using an ID that was created by however you define the destinations in the visual tool, or directly in the XML if that is your preference. Some of the other things that are interesting about navigation is it makes it very easy to pass data between these destinations. So it's usually more helpful to pass the data that a destination needs rather than exposing a global that everybody has access to. And the typical way to do that in the Android world is to pass a bundle. Well, SafeArgs wraps on top of that, so you don't have to deal directly with the bundle API, a little bit more boilerplate, but also not very type safe. But SafeArgs makes it type safe and easy to deal with to pass this data back and forth, both to put it into the bundle, shove it across the wire, and then be on the other side, receive the data, and use SafeArgs to unpack it in a type safe and easy way. We also made it easier to have these single activity UIs. Multiple activities was the original classic way of writing Android applications. Every new screen of your application is going to be literally that, a new screen. It's going to pop up a new window, and then we have this window animation. Everybody got really used to it, but it's a bit of a clunky interface, right? It's a bit dated. A lot of times the Chrome of your application, like a lot of the UI and functionality of your application, is really the same screen to screen to screen. So it's kind of nice to be able to preserve that instead of making the users see this transition between each of these screens every time, even if you're only really changing some of the content in the middle. And so we recommend using a single activity model, but maybe it's not easy how to see how to get there, especially if you find fragment APIs complicated, which I think many people do. And so navigation hides a lot of those details and makes it easier to deal with both fragments because it embeds a lot of those details, implementation details internally in the navigation component, but also in terms of actually dealing with the single activity model itself. And up versus back is one of those confusions. Like it wasn't clear how applications were supposed to handle this, or if it was clear, applications weren't necessarily doing the same thing. And now if you use navigation component, that just handles it for you. When you hit back button, it does the right thing. If you're using the action bar for the up button, that does the right thing, and you don't really need to worry about those. And also has support for dynamic features, which is the ability to actually navigate to a destination that maybe doesn't even exist on the device yet because it is a dynamic feature module. And that will be automatically downloaded and instantiated on the device, and you can navigate that to that at runtime. Work Manager is another one of the architecture components APIs, allows you to more easily run deferrable work. In the background, it is not a replace for do this thing now, but rather a replacement for a very common model of someone saying, I need this to happen at some point with the following constraints, and then they would end up writing a lot of code, and then handling different code paths depending on what version they were on, whether Play Store was on the device, et cetera, what capabilities they had on the runtime device. It goes back all the way to API level 14. You can think of it as embedding all of the capabilities that you had to put in your application code before directly in the library. So now you have one single API to do all of that stuff. It allows you to do periodic tasks. You can chain these things or run them at the same time. And you can also build in constraints. We'll take a really quick look at an example here. So let's say we want to run 3 different filters on a given image, but we don't want to do it if the battery is too low. And then we want to compress the result when all of those are done, as long as we have enough storage. And then we want to upload the result as long as we're on a network where that is not going to be an expensive operation. So the way we go about Work Manager creation is we create this worker, we override this do work, implement this do work thing where we actually do the thing that we're asking to be done. And then we create constraints. And here we're going to say, okay, well, I need the battery to not be too low when I do this. And then I'm going to create the request here. I'm going to add the constraints to it along with the worker that we created earlier. We do that for all of the filters. And now we can say, okay, I want to run all of these filters together and then queue the work. Or if I want to follow this on with the upload and the compression and the upload thing, then we can chain these things to the end of that. There's also support for establishing and using foreground services, which is increasingly important since you can't do as much from the background as you could before for protecting user experience and privacy and making sure that permissions are being obeyed and all that. All right, so moving on. Camera X, I mentioned this really briefly before. This is about making it much easier to write camera applications, both in terms of the support that we have on a single API. So we have this library that works across these releases because it's an unbundled library, but also we're able to embed a lot of the workarounds directly in the library, just like I said, Work Manager does, to support this really diverse ecosystem. So a lot of the devices ended up having different camera capabilities, which are difficult for developers to deal with directly in their code. Like it's not obvious, you know, am I on this kind of phone or this other kind of phone, and then they need to put the workarounds in their code. So we're trying to put that in Camera X itself to make it much easier, give you one API to target, and then you get much better functionality across the ecosystem. Also easier to use APIs. They focused not so much on like the broad span of capabilities that we may have in Camera 2 for doing everything, but rather on the specific use cases that developers really needed for most of the stuff that they needed to do. They want to launch a preview, they want to take a picture, they want to be able to save a file, they want to do some analysis on that image. So pretty straightforward stuff. So let's take a look at a really quick example. So here we're going to ask for a target resolution size. The interesting thing here is this will succeed. If you're using a more specific platform API like Camera 2, if you ask for a target resolution size, if that size does not exist on this device for whatever reason, then it will return an error and you have to figure out something else. So you have these iteration loops in your code to sort of figure out, well, how is this going to work? And Camera X, it will succeed. It will figure out something appropriate that is close to what you asked for, because that's really kind of what you want as a developer. And then we bind, it obeys life cycles. So you don't have that situation where you're going to run out of these limited resources because you forgot to close the device at a particular time, and then you take the picture. So the APIs are pretty straightforward, and the model of working with the API is a lot easier as well. Meanwhile, all of these APIs are coming out really frequently. Every 2 weeks, there's another set of releases. Most of those are sort of incremental releases in alphas and betas and RCs, and then occasionally going stable. A lot of those, again, are sort of bug fix releases, but there is this sort of constant growth of functionality and fixes in the Android X world. And there's constantly new APIs and functionality in development. Jetpack Compose is in very active development right now. It's in alpha. Hilt is in alpha for dependency injection. Paging 3, as we talked about already, also in alpha. And that was it for APIs. Let me very quickly talk about distribution. The fourth category, specifically Android app bundles. So this is the modern way to distribute applications. So App Bundles was launched back in 2018, and that's the only timeline detail you need. It's out there. It's been used for a while by many developers, but more people should get on board. So the problem that it is solving is really that users are a lot more sensitive to space on their devices than is easy to realize, especially if you're in the development world. Maybe you are used to devices that have a lot of memory, and we don't really worry about that sort of thing. But if users are using phones where there's less memory for storing everything, then it's more likely that they're going to uninstall your big application to install a different application, or maybe they're not going to download yours to begin with because they simply don't have enough space. Not only that, but it's more likely the larger an application is, this is data that we track down, the more likely it is that they're going to uninstall that because they need other things on their device and they really have limited memory in which to put those things. In addition, the larger an application is, the more likely there is to be some sort of failure, whether it's downloads, bandwidth issues, installation issues, running out of space, whatever it is. The larger it is, the more problems you're going to have actually getting onto the user's device to begin with. On the flip side, the smaller an application is, the data tells us that the more likely it is for you to have more installations of that application. So along comes app bundles. I like this animation. It's a good way to visualize what's happening. You can think of app bundles as being the monolithic API that Romain was talking about before, except where that was a problem because it forces all users to download everything for their device, whether they have those configurations or not. App bundles have that monolithic thing, which is called the app bundle, but then at install time from the user, they can look at the user's device, figure out what their configuration constraints are, and only download those bits. So basically, they build an APK in the last mile. At the last moment, they can say, okay, this is the set of constraints that this APK needs, and they will shrink that down to that specific APK for that specific user and device, and then that is the stuff that gets downloaded. So saving a lot while not forcing you as a developer to deal with the headache of managing all these different APKs for all these infinite numbers of configurations. So one way to visualize it here is you have this basically monolithic app bundle thing, but then depending on the user device, it downloads different versions of it. Dynamic feature delivery, similar sort of thing, but then you add in the complexity of having these dynamic feature modules. And again, it can figure out at install time as well as at future feature usage time what it is it needs to download. There's been pretty good uptake so far. Over 500,000 apps in production are using app bundles. 35% of the active installs going on are using app bundles, and nearly half of the top apps and games are using it. An important data point that everybody probably cares about is we're seeing an average size of 20%. So the important thing to note about this is it's automatic. If you build an app bundle, in general, you're going to see an APK size savings of 20%. Just because you built that thing, as opposed to managing your monolithic APK approach. An important point here is, I believe it's in the second half of next year, app bundles will be a requirement for new apps. So right now is an optional thing that we are encouraging people to take advantage of because of all the reasons that I just went over. In the long run, as in like a year from now, you will need to use app bundles because it really is the right solution. So we're having people do that. Developers use app bundles for new apps starting then. So really quickly, these are the pillars that we went over: the language, tools, APIs, and distribution. So we talked about Kotlin, we talked about Studio, we talked about the APIs, essentially Arch components and app bundles for distribution. A couple of URLs if you want to learn more. First of all, we have a landing page for modern Android development that has an overview and more information and links in much more detail than we went into in the last 50 minutes. And then finally, we just came out with a new series on YouTube, as well as articles on Medium, called Mad Skills, where we're basically coming out with content that teaches you deep dives into specific areas. So we just finished a series on navigation just last week, where I had 4 different episodes on different aspects of navigation component and how to use that, along with a Q&A with Ian Lake from the engineering team. And then this week we start a series on app bundles. The first episode is probably posted by now. If not, then I've leaked that information, and shame on me. No, there's not more. There's just a thanks.
Yeah, but we have time for questions, and I see there's a bunch of questions already in the Q&A.
Awesome.
So I guess we should get started.
Yes.
So Jean-François, I can just read the questions and we can start answering them.
Yeah. Wasn't me, it was brilliant.
Hello. I will ask the questions. Okay. First one, with all the technologies available to create on Android cross-platform application like React Native, Flutter, or progressive web apps, do you think that developers will stick with the native way?
So it's funny because I mean, Chet and I have been doing this for a long time, and Chet for longer than me. And I remember 15 years ago, we were having the same discussions for desktop platforms, cross-platform versus native. Honestly, I assume that question will always be there, and there will always be a reason to choose one versus the other. And I don't think there's a universal answer. Like, if you have a very small team, let's say you have 2 developers because you're a small company, you're a small startup, and you have to publish on multiple platforms, it makes sense to go cross-platform. Now, if you have more resources, or if you target only a single platform, like, there are tons of benefits in targeting native. For instance, on Android, that means you can our APIs are written in Java, right? So you can use them from Java and Kotlin. Use those programming languages. You don't have to write any kind of adapters, any kind of glue code. You will always have access to the latest APIs provided by the platform. You don't have to wait for those frameworks to catch up after release of Android. So it really depends on what you're doing. There's a reason both exist. Both techniques have existed for the past 40, 50 years, and they will keep existing for a long time.
Okay, next question. In your everyday life, are you a Java or Kotlin developers, and why?
So actually, I write more C++ and GLS code than Java or Kotlin. But yeah, when I do write non-native code, it's Kotlin. The main reason is because I like it better. And also, frankly, I've been writing Java code since '97. So I was a little bored of it. So it's nice to use something different. How about you, Chet?
I am doing, I think most new code that I write right now is Kotlin. I took longer to get on the Kotlin train than some of the other people on the platform team, because most of the code I was writing prior to that was for the platform, and all of that code, the platform code that we ship, is still Java programming language. But when you're writing either apps sitting on top or the unbundled libraries, then you start to have a choice about what you can use. So more lately, in the last year or so, I've sort of switched to doing primarily Kotlin.
Thanks. Next question from Jean-François. Who decided to name the version of Android after candies and cakes, and who do we need to convince for the next one?
So that was an idea that started with Petit Four after version 1.0 that came from our program manager back then, Ryan Gibson. Before that, we were using the name of robots, but there are many reasons why we decided against that. So anyway, started with Petit Four.
I think he was particularly excited about cupcake. Petit Four was prior to that, but I think they really locked onto dessert starting with cupcakes because he really liked cupcakes.
Yeah. And for those who haven't heard, it started with cupcake, the letter C, because we had already used Astro and Bender, which were robots for A and B. But we don't use the dessert names anymore, do we, Chet?
We sort of do. They are used internally. So the releases, as they are under development, they still have an internal name and an internal acronym that goes along with them.
Except we mostly use the acronym. So nowadays, when I see the acronym, I don't even know what it means. I just see
was the last time like RVC or something? Red Velvet Cupcake?
Red Velvet Cake, yeah, something like that.
Yeah. So they're still there. They're just not quite as obvious. And partly because I think Android is so huge that it was becoming a little confusing. We actually have three, if you think about it, we have three different names for each of the releases. There's the dessert name that we all know and love. There is the API version, and then there's the dot, so Gingerbread was 2.3. It was Gingerbread, and it was API version, whatever that was, 14. And so that became a little confusing. I think the desserts, a lot of this was never intended for the consumers, but the consumers got it anyway. And then it was really confusing. Like, well, is this Lollipop? Should I be calling it 5.0? What is the, and so we're just trying to reduce confusion by at least taking away the one that we have a choice over.
Okay. What's the future of Wear OS?
That's a question for the Wear OS team.
Yep. Sorry, don't have a good answer there.
To give a better answer, we are aware of a lot of the things that happen on Android and at Google, but Android is now big. There's a lot of projects, so it's not necessarily that we don't want to answer; it's that sometimes we just don't know the answer. And you would have to talk to the Wear team.
Okay. For both of you, what was the biggest challenge you faced with Android development?
I would say it's a mix. I mean, in the early years, it was mostly dealing with the hardware that we had back then, because it was not that powerful. I mean, it was powerful for mobile devices, but in the absolute, it was not. For instance, GPUs were really weak. And especially since we had decided to use, the Java programming language, running a garbage collector, that was great for the ergonomics of development. And I think it helped us move really quickly in building the platform and the apps. But it also, made it harder in some situations to get the performance we wanted.
I would say similarly, the constraints in mobile development, certainly back in the day, were the hardest thing to get used to. I'm remembering, so in the Honeycomb release, Romain built the GPU, the hardware acceleration for the rendering engine, which I was helping out with around the edges. And there were weird constraints we ran into, like the fact that if you used more than 3 variables in a shader, like the GPU would just fall over. Like the particular chipset on that device, just the power of devices at that time meant that even when we got to the GPU, we still had serious constraints that made us, jump through hoops just to make stuff try to hit some reasonable frame rate at that time. Things have gotten better. There are still a lot of constraints, but just the hoops we had to jump through in terms of things like that at the very lowest layers, or even in APIs. Like this is why a lot of the APIs that you see in Canvas, in Vue, and in a lot of the fundamental classes from way back, we did anything to avoid allocation and collection at all costs, because we would, if you allocate a bunch of little tiny objects on the way, if you're going to keep calling methods that keep returning a new rectangle object, then eventually you're going to require us to do a garbage collection, and that will cause a stutter in your application, given where the runtime was at that time. Things have gotten much better since then. We would probably design some of the APIs more differently now than we would have at that time, but it was a different programming model and mindset that I had to get into.
Okay, with Jetpack Compose and Kotlin multi-platform, will we be able to create a full multi-platform application in the future?
So I guess here the question is assuming that Jetpack Compose will have support for other platforms. So right now the state is JetBrains, again, they're a close partner. They've been submitting changes to support Jetpack Compose on desktop. So you could definitely use Kotlin and Jetpack Compose on desktop. As for other platforms, we're focusing on Android. I don't see any reason why it wouldn't be possible in the future, but that's not the plan at this time.
Which I think is important. Like the thing that we know people are interested in, cross-platform stuff. There are obviously attractions to some of these other toolkits out there. The problem that we were trying to address was we needed to simplify Android UI development. Like priority number one from day one on Jetpack Compose was looking at the problems that people had, developing Android UIs and Android UI applications, and trying to modernize that and make it simpler. So that's what the team focused on.
After the release of Jetpack Compose, will the legacy Android view be deprecated?
I don't know. If they end up being deprecated, it's not going to be for quite a while. There are several reasons, right? So first of all, we would need a lot of the ecosystem to move to Jetpack Compose, which we know is going to take a long time. Also, frankly, we use views in a lot of places, including the system UI on Android. So there's no reason for us to deprecate something that's still used heavily by the system. And you can see what we've done, for instance, with the Java programming language and Kotlin, right? We support both. So I would expect to see all the new features or most of the new development to go in Jetpack Compose, but I don't think we can talk about deprecation at this stage.
In fact, one of the things that the team tried to figure out early on was how to have Jetpack Compose live in a world with views, because it seems pretty important to allow people to migrate and to use both models in the same application, because of the realization that people aren't just going to drop everything on the floor and then rewrite into the new programming model. Instead, maybe they have complicated custom views, maybe they just have a lot of legacy code sitting there. They want to take advantage of a better programming model for this new thing that they're doing, or maybe they want to rewrite along the way. But we expect the existing stuff to be there for a while.
And there's a related question at the bottom of the list. Someone asking, do you think using XML to build UI will change for another techno, maybe a reusable UI atomic components approach, or etc.? Well, we think this is Jetpack Compose. This is definitely our solution. We really encourage you to take a look at it and give us feedback. We've been developing Jetpack Compose in the open since we unveiled it at I/O in 2019. And you can join the Slack channel on Kotlin Lang. You can talk to the engineering team directly. So we are talking with you, the community, every day, and making changes to try to deliver something that you want to use and that answers your needs.
Next question. What do you think about standardized UX UI between iOS and Android?
So that I have to answer to that. As someone working on the platform, right? As someone working on the Android specifically, I think what matters the most is that you give your users what they want and what they expect. So, if you're a game, obviously, that means something completely different than if you're an application. So for the specific case of applications, unless for branding reasons or whatever other reasons you might have, it is imperative that you have the same UI UX. You should go with what your users expect from the system. Just like I don't want as a user to see an iOS experience on my Android phone because I'm used to the Android isms, right? The gestures, the looks, the behaviors. I also don't want to, if I were an iOS developer, I wouldn't want to give an iOS developer user an Android experience because that's not what they expect. So I think, it's about the user and it should always be about the user, and that's how you get to the answer.
When you chose Kotlin, did you also look at Dart?
We looked at a bunch of languages, Go, for instance, and other languages, Rust, I think. But Kotlin.
Fortran.
Not quite. But Kotlin was almost a no-brainer for two major reasons that we already discussed. The first one was the Android community was already really actively using Kotlin, and clearly that's something the community had decided that they wanted, that's what you had decided you wanted. And also it's the interop story, right? And we've seen the success, the adoption of Kotlin has been really, really high, really quickly. That's because the next class you write in your application can be in Kotlin. You don't need to rewrite. You don't change IDE. You don't change tools. You don't change workflow. Learning Kotlin when you come from Java is almost trivial. You use the same APIs. And for us, like, you know, that reason was so good that the rest almost didn't matter. But so yeah, we looked at other languages, but it didn't make much sense. Go, for instance, is a really nice language, but it would have been hard to make the transition.
And we got that feedback from developers too. This wasn't just us making a gut call. We had conversation with developers for years asking, you know, what is it you think we should focus on? What are the priorities to you? And every time we mentioned the language question, the answer was, please stop thinking about that. We do not need a new language. We have other problems that we really want you to spend your time on. Until we mentioned Kotlin, they said, oh, well, no, we could do Kotlin. And it was really all about the interop story. It was very easy for people to use Kotlin coming from the old world or even still being in the old world. And the same is not true for any other languages that we were talking about.
Next question. Do you have common architectures or guidelines between Google applications, or is it up to each team to come up with their own? And in that regard, do they all take advantage of the awesome tools of Jetpack?
Well, the answer is all of the above. It's like your application. So we have Jetpack libraries that we provide as the Android team. We have our guidelines. Google Apps don't have to follow those. A bunch of Google Apps internally have their own frameworks that they've been developing over the years. Very often it's because they have specific needs that are not addressed by what we do. There are several apps that use the same frameworks. Some apps use their own framework. So it really depends on what they're trying to achieve. Also, some of those apps are cross-platform, so they're trying to share code, between the different platforms that they target. The key is that we have those tools available, we have those guidelines available, but they can't obviously address the needs of 100% of the development community. So just like with third-party developers, our first-party developers, sometimes they take Jetpack stuff, sometimes they don't. In practice, what happens is that it's a mix of both, right? They will take some Jetpack libraries, but not all of them. It really depends.
Thank you. Any thoughts on the Android distributions, Lineage, Replicant? Where these communities able to contribute back to the main Android project?
I mean, the fact that those distributions exist is a testament to Android being open source, and those ROMs, like they used to be called, have existed since the early days of Android, since basically the day one. And I think it's great, right? It brings innovation. People are excited about the platform. They can do things that we're not going to do because it's not aligned with what we think is best for our users or our devices or whatever. So it's fantastic. Contributions, honestly, I don't know because I've been focusing more on Jetpack over the past few years. I'm not entirely sure what kind of contributions we've been getting on the platform, but I do remember contributions in the past. I just don't know much more than that. I don't know if you have anything to add, but.
Okay. For both of you, what is the feature you were the most proud to ship?
I guess two of them. Android 1.0, because it was a lot of work. So it's not quite a feature, but it's a lot of features. The other one was one that we worked on together with Chet. So that was the hardware accelerated rendering for the Android UI. And the reason for that is, A, it solved a lot of problems we were having. B, it was done really quickly, which caused some issues afterwards. But yeah, it was very challenging from a technical perspective, from a project management perspective. So getting it out the door, even if it was not perfect, it was nice to see it happen and work and help actually do what it was supposed to do.
That was certainly the hardest release that I worked on. That whole Honeycomb release and the push to get acceleration in there was pretty intense.
Yeah, intense is a way to describe it. Scary and stressful as well.
Yeah, all of the above. Mine has to be the animator APIs and just sort of animation functionality in general, kind of because that's what I came there to do. That was my entree into the group was the animation APIs were fairly limited at the time, and we needed something more robust. I would say aren't as much as we need, and we continue working on those things, including a new animation system in Compose. There's the new motion layout and motion editor, which I think are a richer approach to doing UI animations in some ways, but just at least brought the platform, I hope, to a level where a lot richer things could happen in a more correct way, so that you didn't click over here and the button would highlight over there because of the way the animation system worked in the old days.
Yeah, another feature I really liked working on was column management for Android, because it's something like I personally care about, and it was hard. Like, it was complicated from a technical standpoint because I had to make changes. Like in ADB, in the ID, I had to fix the JVM on macOS to get that feature to work, which, you know, is interesting. It took me there. So yeah, that was super interesting, and that's something that, you know, yeah, I really wanted to see in the platform.
Next question is there a way to access resources or classes of another application precision that know each other? So
Well,
developed
if you think about it, that's what the launcher does. Like for the app widgets or the app icons, it accesses the resources of your app, and you know. So yeah, it is definitely possible. For classes, I know it's possible as well, but I don't know the details. It probably involves like class loaders and stuff like that. And I don't know what the recent changes around security that we made over the past few releases mean. But I know it's definitely possible to download classes after your app is installed and to load them. But yeah, I don't think I'm not the right person to answer. Chad, do you have any idea?
I am also not the right person to answer. I know that we did start restricting what you could see of other applications in general. Just getting access to even finding out what other applications are installed on the device is more limited in the latest release for privacy, user privacy reasons. But as far as what you can get into those in the applications, I'm not sure.
What are the key projects you are involved in?
So many. So I now manage the toolkit team, which has grown to, it used to be the Android UI toolkit, and then it started adding the support library and a bunch of Jetpack libraries. So effectively that team nowadays, that's the team that Chet used to lead. Actually, it's funny because I managed that team, then I gave it to Chet, and then Chet gave it back to me. So Chet is a very nice man. He gave me back my toy that I gave him. So yeah, it's all of Jetpack. So that implies like not only a bunch of the libraries that you're aware of, like, you know, Jetpack navigation, room, and so on, but we also build the infrastructure that is used to deliver Jetpack to the rest of Google and to just make Jetpack possible. We ship Jetpack every 2 weeks. So I think in the past 12 months, we shipped something like 1,000 artifacts across like over 100 libraries. So we have a lot of internal tooling that we have to maintain. Plus, we're involved obviously with the changes in the platform, the view system. We're doing Jetpack Compose. You know, we work with the tools team. We work with JetBrains. So we do a lot of different things.
And I've become more of an outreach person. So I have, even way before I joined Android, I've always basically had as a side project doing outreach talks and articles and samples and whatever. And then
yeah, I remember when we first met, 15 years ago, you were already telling me that you were thinking of becoming DevRel someday.
Yes,
took you 15 years.
Yeah, continue to think about it all the way up until about 1.5 years ago. So I switched over to doing that full time, which means I still write a little bit of code, but not for the product, more as research into how things work so that I can better explain how that goes. So my projects are more along the lines of like starting up the new Mad Skills series, where we teach people how to use these technologies and then work with other people on the team, as well as the engineering teams, to understand things. There are other people on the team are contributing to this series as well. So it's a bit more sort of higher level, kind of figuring out how to get the information out there that developers need to do this stuff. And then like 6 months ago, I used to travel a lot too, and that just completely fell away. So now I travel from my bedroom to my office and then back to my bedroom. Yeah.
Yeah, that was nice.
Yep.
Next question on the futures of phone. What do you see as the future of phones? Will it be a photo phone, a smartphone, or something else? What are the new area of innovation on Android?
So the future of phones, I honestly have no idea. I mean, I guess the best guess I can make, which is not that much of a guess, like, more machine learning. So we're going to see like more automation, prediction, what we call helpful innovation at Google. But yeah, and I guess that answers the new area of innovation around Android. It's like, using more machine learning and intelligence in our features.
I assume that they're going to come back with that, like the ring dialer thing, because everybody's really tired of touch.
John Hofford, for a new feature of constraint layouts, they just published. He published a tweet, I think, this weekend where he built the rotary dialer from the old days. That was awesome.
Probably because the math was really interesting to make it work.
Yeah, they have support for polar coordinates now.
Yeah.
Are Android teams in remote? How does this impact productivity, creativity, innovation? Would it have been possible to be remote in 2009 and release Android?
Yeah, so we currently at Google and Android, we're not going to the office. So everybody's remote. And the transition has been fairly easy for the most part. Of course, like it depends, from person to person. But at least, as far as my side of the world is concerned, like we haven't seen a big impact. It's definitely, in a way more difficult and more exhausting for many reasons. And it helps because, our team, we have a lot of people who have been on the team for a long time. So they know each other. So we're able to transition quickly. And our team is already distributed. So we have folks, for instance, on the East Coast, on the West Coast, and in London. So we're already working somewhat remotely. So we're not caught by surprise. And the rest of Google is the same, right? And of course, we have our own tools like Google Meet and Google Chat, and we're used to using them all the time. As for Android possible in 2009, it's hard to say. I don't know. I'm sure it would have been possible because I don't see any reason why not. I just know that the teams were working really hard and were extremely flexible. A lot of what's happening with like on-the-fly discussions that may have been harder being remote. But yeah, it's really hard to say.
Actually, from what I heard from the team, they kind of did build all of Android 1.0 at home. It's just that everybody lived at work.
Yes. It was a reverse remote.
Yeah. It's an interesting question. Like, I wonder if you could build, I think there are some tech or even other companies and domains where it would be difficult to start something when everybody is remote, where you do not get that really intangible collaboration and cooperation that you do when you are in person and you bump into that person in the micro kitchen and you realize, oh, I had a question for them. And also access to hardware and specialized devices in the early days. Like, I think there were certainly elements that would be more difficult to figure out if you started there.
Yeah, good point. Especially for the teams like the kernel team, or a bunch of people need hardware. And so I remember the desks being covered in oscilloscopes and like pieces of phones and stuff like that. Again, I'm sure it's doable remotely, probably a little harder for different jobs.
Next question. Is it possible to use dynamic modules delivery with my own server, probably without Play Store? And if it is, please tell me how.
That's another one of those, I'm not familiar enough with that technology. I am sorry, I'm going to have to punt on that. Do not know.
Okay, next one. Is there a way to pass non-parcelable objects between applications?
So yes and no. Yes, because parcelable is a very specific form of serialization. But if you're going to go across processes, you will need a form of serialization. There's no way around that. So it doesn't have to be parcel. You could do your own thing. I mean, it can be JSON, it can be protobuf, whatever you want.
Save a file on the hard drive and then load it.
Saving files is hard. But yeah, like every process, has its own runtime. So you can't just share an object like that between them.
Thanks. Next one is about the manifest attribute process. Is it only for task management?
Yes, so that's if it's what I think it is, it's the ability for APK to say like which process you want to be part of. it mostly made sense a long time ago when we had limited resources, and we did take advantage of that in some of the built-in applications. So for instance, the process that was hosting the launcher, the home screen, also contained other things. I don't remember what exactly, but I believe there was maybe the contact provider, stuff like that. So we would have like only a single process because we need all those things to be alive most of the time. There might be reasons to use it as app developers, but I can't think of any. But I'm also not the right person to ask that question.
Next question. Could we have this delicious PowerPoint at the end, please? I may have to do a little summary tomorrow to my team, and this helps a lot.
I will send a PDF to Jean-Francois if that helps.
I guess. Jean-Francois? I'm not sure he's still here. We'll see after.
Okay.
How can he distribute the...
Right.
Okay, next
See
one
the
is...
one about fragments and activities.
Yeah, it's mine.
Oh, okay.
You can answer.
I can
Who
speak
or
directly to you about
decided to
that.
push app towards fragment first instead of activities?
Yeah, so I think of this in a couple of different phases. I mentioned this earlier with the single activity model, and that is really the second phase. The first phase was Diane Hackborn realizing as we went into the Honeycomb release that we were really dealing with an entirely new class of devices where you're going to have a much bigger screen. Applications were going to want to have a different layout entirely, including using what used to be activities as a subpart of their activity. And so the idea of being able to reuse these essentially layouts or containers in a much better way, instead of having separate activities, and then you have a different tablet version of your app where they are all in the same activity. Instead, Fragment became that new atomic containment thing that you would pass around. And so it was really intended to bring the idea of activities more into a model where you could have these sort of reusable chunks that you could pull in different ways depending on what the form factor of your screen was. So that was step one. And then step two was more recently saying, even on smaller phones where you're not going to have that expanded screen experience, you still want the ability to then keep the single activity model and then swap in this thing inside. And whether that thing is a view, a custom view, some custom layout you wrote, or what we offer in the platform and now increasingly in unbundled libraries is Fragment. Like you need some model of that thing that you're passing around, and that is Fragment. And hopefully along the way, we've fixed a lot of the bugs, simplified and fixed a lot of the APIs, and made all the fixes and functionality reusable across releases, because Fragment used to be a platform API, and now you should use the Android X version, as well as build navigation on top of it to make it all easier to use.
Thank you. Next question. According to you, would you say that the frameworks, Flutter or React Native, for example, allow constant development and the scalable, flexible maintenance compared to the native language or Kotlin?
I'm not sure I understand what constant development and flexible maintenance
Maybe it's consistent. I don't know. I'm not sure I understand it either.
I mean, it's hard to answer like without using those. Well, first of all, we have a framework as well, but without using those frameworks myself. And again, it really depends on what you're doing with them and why you're doing it. So I can't really answer that question. I mean, I think the key is to always remember that all those things are just tools, and like with any tools, like pick the one that matches your needs and that helps you like with your goals. And the answer will be different for everybody.
I know, not related to that question, I think Romain had to go. I don't know when you need to stop.
Actually, my meeting moved, so now I have time.
Okay, then we'll stick around for a few more.
Yeah.
Cool. Let's keep on. About libraries, did you use for some of your projects some libraries not shipped by Google, like Square libraries, or tools like Canary?
I've used OKIO, for instance. I've used other libraries in the past, but I got to admit that on my spare time, I do not spend I do not spend my spare time writing Android applications that often. So yeah, I've done it, but
and I would say most people should, right? I think we do not try to ship everything that you need in writing a robust application, depending on what the domain of that app is.
Well, especially when,
yeah,
especially when we see that they are already like, you know, when we see OKHTTP, OKIO, Glide, like those libraries are great. There's no reason for us to come up with the same thing.
Yeah, we've been saying for a while, if you're loading bitmaps, certainly from the web, then you should be using Picasso or Glide or some other bitmap thing. We're not providing anything, and it's a lot easier than writing the code from scratch. And then recently we talked to the person behind Coil. I was looking at that this weekend saying, you know, well, I want to play around with some image loading stuff, so it makes sense to do that rather than going directly to the bitmap APIs.
I made a contribution to Coil last week.
Maybe we can extend the question to internal applications like Play Store, whatever you develop. Do you use that kind of libraries?
I don't know. I mean, Google uses third-party libraries, you know, all over the place, not just Android apps. So I assume some apps do use external libraries. I don't know what libraries and what apps.
Same question as before. Like there are many, many teams writing many, many apps, and they all make their own decisions, and we don't know what they are.
Yeah, I guess they are Android developer as we are.
Yep.
Is there a part in Android AOSP that can be changed, like changing the class widget, have a boost up clock with wonderful animation with a refresh rate of 20 milliseconds per frame?
So first of all, 20 milliseconds per frame is a terrible refresh rate. That's not even 60 frames per second. So I assume that's not what you meant. Yes, there are things that cannot be changed. We do have a suite of tests called CTS that, you know, an Android compatible distribution is supposed to pass, like if you want to sell an Android phone. And we do test a number of things. And also, even if you somehow manage to find something that is not tested by CTS, you should think of what it means for app developers. You don't want to create surprises or incompatibilities or, you know, fragmentation, basically.
Thanks. Okay, so I know that you're not in the Wear OS team, but can you tell us how Wear OS act like a proxy through Bluetooth and give internet to the watch without Wi-Fi on the watch?
That's networking, and I don't know enough about networking, but I assume it's the same thing as, you know, you can use your phone as a hotspot over Bluetooth from your computer. It's just protocols on top of protocols. I don't know exactly what Wear OS does, but ask a networking expert.
The magic of software. Yes.
You take the bytes from one place and you send them to that other place, and you're done.
Is there a library hotfix that you recommend, like Tinker, can update your app without a store, like a dynamic delivery, I guess?
You can update your app without a store. Again, like, you know, this is all bytes, so I assume you can always like download like code on the side and just load it with your own class loader. But yeah, you can create your own app store, right? On Android, there's a number of like I don't remember the names, but there are app stores specifically, for instance, for open source projects. So you can just install APKs. That might be a way, but I don't know much more than that. Sorry.
Okay, next one is bitmap versus drawable. Which one have better performance, memory, faster to create?
So there's a subclass of drawable called bitmap drawable, which contains a bitmap. So it depends on what drawable you're talking about. I mean, a bitmap will, so if you're talking about the other kinds of drawable, like gradient drawable, shape drawable, vector drawable, those will most likely take up a lot less RAM than a bitmap, because a bitmap, you know, we have to hold all the pixels. It depends. A very large bitmap can be slow to draw, especially if you resize it. But, you know, a very complex vector drawable can be slow to draw because we have to re-execute every drawing operation. So sorry for the non-answer, but it depends. I would say, as always, like go with what is the most comfortable thing for you to use. And as long as you're getting the kind of performance that you need for your app, then you're good.
Next one, any news about Fuchsia? Will it replace Android?
So we are not on the Fuchsia team, so ask them.
I'm working with someone that uses a system file to command LEDs on the hardware. So the device is rooted. Is it a good way if we want to sell the product? Yes, the question is about rooted hardware on the market. And can you suggest an efficient way to use LEDs or hardware?
To use LEDs?
Yep.
I mean, in general, it sounds like a bad idea to have to ship a product where root access is available. Depends on how you make it happen. Certainly on Android, like, you know, we have some processes with privileged access to the system, but I don't think anything runs as root by default. But that's external my knowledge. Also depends on the product. Sorry.
You know, I would assume the typical model we recommend is exactly what all of our partners and the manufacturers do, which is you get AOSP and then you make your own changes to it to make it talk to your hardware and your drivers, which are dependent on your situation. And they're not doing that by, you know, making sure that there's root on Samsung to do something special. They're doing it by inserting code at a low level of the platform to do what they need to do. Whether that's too much work for you to do for a specialized device,
Okay, next one. Is an application better referenced in the store if it's coded in Kotlin instead of Java or Cordova, etc.?
I have no idea. That's a question for the Play team. But I'm not even sure how we would decide if your app is in Kotlin versus Java. So I doubt it.
And the last one. Navigation framework looks cool, but how do we manage cases when you need to use multiple activities, or when do you need to use different themes between screens? Seems to be such a pain with fragments.
Yeah, a couple of different things going on. You can, so the default and typical way to deal with destinations in navigation component is using fragments, and there's basically a container in the middle of your activity somewhere in your hierarchy where those fragments are swapped in and then the rest of the Chrome stays the same. However, there's nothing to stop you from creating a destination, which is an activity or a dialogue that pops up outside the application. It's still the easy to use navigation component as the driver and the designer of all of those different flows through your app. We recommend using fragments, but you do not have to. So you can still have a multi-activity application and use navigation component with it. And then the next one was, yeah, different themes. I mean, if it makes sense for your application to have multiple activities, we're not saying don't do it. We're saying these are the reasons why we think that is maybe not the best solution anymore. There are clearly solutions. There are clearly reasons why you still may need multiple activities, even in a case where you have a single activity application for the most part. Maybe you have a deep link somewhere in your application and you want people to be able to get directly there, and you need to expose that as an activity, for example, then that still makes sense for that to be an activity destination in the navigation graph instead of a fragment destination. Oh, an architecture question. Our favorite.
Some people recommend to use other architecture schemes like MVI, MVP, MVC, or MV star. What do you think about these?
I think they're all lovely. Our answer to this, like traditionally for the first 10 years of Android, was we really don't care what you use. Right? That decision of application architecture is up to the people that write the applications. We write the pieces that you put together that you build into an application, but how you structure that is irrelevant to us, right? Our stuff is below that level. However, this resulted in some confusion in the community, and people looked to us, or at least a single provider, to say this is how you should approach things. So eventually we came out with guidance and said, okay, here's our opinion on architecture, and you can take it or leave it, right? So we will offer things, the architecture components build around a particular architecture, which if you like it, great. And if you don't, That's fine. You can use your own architecture. Again, we are not opinionated about how you build your apps. We are very opinionated about how we build the platform.
Yeah, and again, to hammer that point home, like, you know, if I were to write an app for myself on the weekend, on my spare time, I honestly don't care that much about how my app is architecture, as long as it helps me, like, you know, have code that's easy to maintain, to read, to extend, and so on. So I would just go with our libraries, because that way the problem is solved. You know, I know I have tools, I know I have resources. But again, like, if you want to do it differently, that's completely okay. There's not one way of doing everything, especially in our field. So do what's right for you.
I think to the main thing, I think that like coding style, like exactly what style you use in your code is way less important than using a consistent style across your code, right? So that everybody on your team understands it. So I think it's kind of irrelevant which architecture you pick. Maybe there's some bad ones. I don't know. I don't have opinions on these. But I think it's more important that you pick an architecture and you educate the people on your team about how to go about that, so that you don't have different people on the team taking different approaches. Therein spaghetti lies.
And this will be the last question for tonight. Is it possible to create an application that handles multiple sub-applications?
Yes, I mean, if you mean multiple APKs that run into the same process and stuff like that, yes, very much so. Again, that's the kind of stuff we've done in the past. Without knowing more details about your particular use case, I can't really say more. But yeah, I mean, that's why, you know, that's also why we have things like intent and activities that are a way for you to like cross app and process boundary, but have a task. As far as the user is concerned, it's the same workflow. So there are multiple ways you can do that on Android. There's definitely an area where I don't think we have an opinion, because this is not a common thing to do. And there are persons who would be better suited at answering that question than Chet and I.
Okay, that's it for questions. I'll leave it to Jean-François now.
Thank you.
Thank you again, guys. So you have time of question. Congrats. Congratulations.
That's what we do.
Thank you again. I will stop the stream and we will go again in the table mode. So if some of people want to ask more questions because they were too shy to write it, you can try to reach Romain and Chet directly on the table. So thank you again, guys, and see you.
All right.
Thanks.
Thank you.